Welcome back everyone, my name is Pedram and this is where we do advanced time series analysis, deep forecasting. Alright, this is our module number 1, Demystifying time series data and modeling, part 2. In part 1 we talked about time series basics and we said that we're going to rely on them when it comes to the modeling section of the course. But before jumping on the modeling, let's figure out what do we mean by forecasting strategies. So here's part 2, forecasting strategies. One-step versus multi-horizon forecasting, univariate versus multivariate forecasting, and benchmarks. Let's start with forecasting horizon H. If H is equal to 1, we are doing one step ahead forecast. So here's an example. Imagine you have a model which is using the past 4 days of information to make a forecast for tomorrow, right? Imagine this is daily data. So here we are, this is time is equal to t, and we have access to the actual data in the past 4 days. So blue ones are actual data. And we're going to make a prediction. We're going to make a forecast for tomorrow. So the red ones are the current forecast. So then this means that if you want to make a forecast for the day after tomorrow, you have to wait 1 day until the actual data is there and use the past 4 information to make a prediction for the day after tomorrow. And this also means that if you want to make a forecast 4 days in advance from now, so let's say you want to make a forecast for here, then you have to wait 3 days, right? So you have to wait 3 days to get access to the actual data and then make a prediction for 4 days from now. So this is called one step ahead forecast when the forecasting horizon is equal to 1. Now, if forecasting horizon is greater than 1, for example, it can be 4, then we call it multi-horizon forecast. But for multi-horizon forecast, we can do it in 2 ways. Either do it iteratively. If you do it iteratively, it's multi-step, or do it all at once. It's going to be called multi-output forecast. So let's start with the multi-step forecast. So here is the same example. Day 1, you want to make a forecast for tomorrow. Your model is going to use the past 4 days of information to make a prediction for tomorrow, right? And right now, if you want to make a forecast for the day after tomorrow, you can do it. You can do it right now. So this means that the model is going to use the past 3 days of information and also use the predictions from yesterday, right? So this is going to be your prediction. We can show it with y hat. These are previous forecasts, right? And then use these 4 observations to make a forecast for the day after tomorrow. So that means that if you want to make a forecast 4 days from now, you can do it. You don't need to wait 3 days. You can literally use the actual data and then the previous forecast from previous steps, right? So the model is going to use this 4 information and make a forecast for 4 days from now. So the difference between multi-step and one-step is that multi-step, if you want to make a forecast 4 days from now, in multi-step, you can do it now. But in one-step, you have to wait 3 days, okay? So this is multi-step forecasting, and then the last one is multi-output forecasting. So multi-output forecasting, as the name suggests, you're going to make a forecast for multiple outputs at the same time. So let's say your model is going to use the past 4 days and create the forecast at the same time. So this means that if you want to make a forecast for 4 days from now, you can do it now, and it's going to create these forecasts at the same time, right? So the difference, so this is going to be our multi-output, and this one is going to be this is going to be our multi-step, and this one is going to be our multi-output. So the difference between the two is that multi-step forecasts are going to create your forecast into the future iteratively using one step at a time, right? Multi-output is going to create all those forecasts at once. So that's the big difference. So what I want to emphasize about these forecasting horizon is that when it comes to model comparison, comparing model is highly sensitive to the chosen forecasting horizon. So for example, if you're, you're using daily data and your forecasting horizon is 1, you're doing one step. So there might be one models might perform better than the others. And when you increase that forecasting horizon, the performance is going to be less stable and the ranking of the models are going to be different, right? So obviously the further you go into the future, these forecasts are going to be less and less stable. And yeah, that's the forecasting horizon that we should pay attention when it comes to forecasting. Another thing that you need to pay attention when it comes to considering forecasting horizon is that which models are able to create those forecasts for you, right? And by which model, I mean which class of model. I mean classic econometrics, machine learning, and deep learning models, right? When it comes to one-step and multi-step forecasts, I would say, let me actually write it down. No, all the models, all the classical machine learning and econometric and deep learning models are able to create these forecasts for you. But when it comes to multi-output, not all the models are capable of doing that. So for example, your traditional ARIMA and ETS models are not designed to create that. Not all the machine learning models are able to do that, but I would say all the deep learning models, so I'm going to write all the deep learning models, and most of the machine learning models are able to create multi-output forecasts at the same time. So again, when the time comes, I'll talk about all the details and which models are able to generate these forecasts or not. One last thing I want to emphasize is that when you are using, for example, some basic packages, let's say scikit-learn, and when you do model.predict and you pass a test set, by default, it's giving you one step ahead forecast. If you want to do multi-step ahead forecast, you have to create a for loop and then basically iteratively use one step ahead forecast into the future to generate this multi-step ahead forecast. So this does not come by default in the multiple Python packages. The next topic is univariate versus multivariate time series forecasting. So on the left, we have a univariate time series. So it's adjusted close for Apple stock price. And as you can see, univariate time series means simply using a single variable historical data to predict its future value, right? So especially for time series that you believe that everything is reflected in that variable, univariate modeling, because of its simplicity and sometimes accuracy, is more preferred. For stock price, if you believe that everything is already reflected in price, you can go ahead and try univariate models as well. And on the right hand side, we have multivariate time series. So basically multivariate modeling incorporates multiple variables to forecast future values, right? And at the same time, you're considering the relationship between these variables as well. So for example, imagine you want to predict Apple stock price, but you're considering a bunch of other variables as well, right? In this case, I'm showing 3 features, but it can be a lot more, right? So for example, you're going to say, okay, the market price, QQQ index price matters, the gold price matters, and then maybe the US oil price matters as well, right? You can go ahead and add a bunch of technical indicators like moving averages, fundamental indicators, economic data, alternative data, and etc., etc. But the point is that the more variables you use, the less stable your predictions are going to be in the long term, right? And simply, we can say that this multivariate time series forecasting cannot be used for multi-step ahead forecasting. And the reason is that it's not that technically it can be, but practically it's going to be challenging, right? Because you need to predict the future values of each of these random variables into the future in order to make sure that you can use them for making a prediction, for example, for Apple stock price, right? So I have 3 more time series here, QQQ, GLD, and USO. And I have to predict, let's say your forecasting horizon is 10 days. I have to make the prediction for them for the next 10 days and then use those predictions and to make prediction for basically Apple stock price here, right? So the idea is that each of these variables introduce its own uncertainty, which compounds in the long-term predictions for the target variable. So for that reason, in this course, we're going to mainly focus on basically the univariate time series variable, especially if the forecasting horizon is long. Because we know that if you want to do multiple variable, we have to access to all those data in the long horizon, which is going to make the forecasting task a lot more harder. All right, let's talk about forecasting benchmarks. So some of these forecasting benchmarks are extremely simple and surprisingly effective. The idea is that you cannot report the performance of your model in a vacuum. So for example, you cannot say, hey, this is the MAPE or this is RMSE. You need to make sure that you're comparing it with a fair benchmark out there. If your model cannot beat the benchmark, basically it's not even worth considering it. So here are the 4 most commonly used benchmarks in practice, and depending on the nature of your time series, you will end up using either of them, right? So for example, if your time series is stationary, if the average in the long horizon is stable, a good benchmark for that is mean method, right? So mean method basically predicts that all the future values to be the average of the historical data. Imagine you have 100 observations. You're going to simply take the average and you're going to use that average as your forecast into the future, right? The next one is naive forecast or naive method. So this predicts the next value to be the same as the current value. So this is pretty straightforward and surprisingly effective, especially when it comes to stock price. So imagine you're using daily data and you want to make a forecast for price tomorrow. You're going to see, okay, what is the closing price today? I'm going to use that number for the forecast for tomorrow. What is the closing price for tomorrow? I'm going to use that number for the forecast for the day after tomorrow, and etc., etc. So this simple method, which you call a naive forecaster, is sometimes very hard to beat when it comes to stock price prediction. The next one is seasonal naive. So seasonal naive, as the name suggests, it's a combination of naive forecaster, but we have to use the right observation from the past season, right? So it predicts the next value by using the same value from the previous season. So what does it mean? Imagine you have a monthly data, right? And then you have monthly seasonality in that data, like airline passenger data. And right now, this is December. You want to make a forecast for next January, right? So you're not going to use December data as your predictions for January. You're going to use previous January data as your forecast for the next January, right? So imagine this is, I don't know, you want to make a forecast for next May. You're not going to use the April data as a forecast. You say, what was the value in the previous May? I'm going to use that one as a forecast into the future for the next May and all the future Mays, right? Okay, so then the last one is drift method. So drift method is simply calculating the predicts by extending a linear trend fitted to the historical data. So imagine you have a data set, you have a time series, it's an upward sloping time series. You're going to connect the first point to the last point and extrapolate it. And those extrapolated line is going to be your forecast into the future. So just remember, as I said earlier, we care about these benchmarks because at the end of the day, if your model cannot beat these benchmarks, it's not even worth considering them. So let's look at some of these benchmarks in the next example, in the next slide, which I hopefully show it to you over a simple example, a couple of examples. All right, here's a simple example for you. So going back to our airline passenger data, which we're using monthly data, you want to see what are the benchmarks if you want to make your predictions 24 months into the future, right? Let's say the blue one is your train data set. The gray one is your basically test set, which is 24 months of data. And I want you to pause the video and label these lines for me. So for example, what is this thing? What is the red one? What is the yellow one? What is this purple upward sloping line? And what is this green line, right? So when you're ready, come back and unpause the video. Okay, so this yellow one, as you can guess, this is your mean forecaster, right? You're simply looking at your train set from this date to, let me actually use the cursor, from this date all the way to this date and take a simple average. And it seems that the average is around here, maybe around 210-ish passengers per month, right? So I'm gonna say that, okay, this is going to be my benchmark going into the future. This is your mean forecaster. So the predictions for the next 24 months are equal to this. Is it a fair benchmark? Obviously not, because your data is showing some upward trend, some seasonalities. So if anything, this is not going to be a good benchmark. So if you create any random model, it's going to outperform this benchmark. So you should not be super excited if your model is outperforming a mean forecaster here, because it was not a fair benchmark. What is your next best option? So look at the naive forecaster. The red one is your naive forecaster. Basically, it's saying that the prediction for next month is the same as previous month. And then because this is multi-horizon benchmark, in the next slide, we're going to look at single output, but this is multi-horizon benchmark. So we're going to say use this value for all the 24 month. Okay, so this is going to be your multi-horizon benchmark, 24 month. Obviously, the ex post, when you see the actual observations in the test set, this red one, this naive forecaster, is doing a better job than mean forecaster. But again, is it a fair benchmark? Probably not, because again, your data set has upward sloping and some seasonality. So what is our next best benchmark? The next one is our drift forecaster. So drift forecaster, as I said earlier, it's as if you're connecting this point to this point, the beginning and the end, and then simply draw a line and then extrapolate it. So this is going to be, actually, it's going to be better than the mean forecaster or naive forecaster, simply because it's showing the upward sloping trend into the future, right? So this is a more fair benchmark. I would consider this one. And then lastly, because this data is showing high seasonality, probably a better benchmark is seasonal naive forecaster. This is a green one, right? So seasonal naive is pretty straightforward. So let's say the data ends in December and the next month is January. I'm going to use the past January. So here, basically, this is going to be my past 12 month of data. So I'm going to use past January for this, for all the Januaries forward. So there's one January here, one January here. I'm going to use February for all the future data, right? So this is February, 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 and etc., etc. So these are the summer days. Maybe this is, I don't know, June or July. Let's say, just for the sake of argument, this is June. So I'm going to use this value for all the future, this value for all the future forecasts, right? So that's why, as you can see, they're going to be repeated like this all the way to the infinity. So this is a better benchmark. It's capturing the seasonality, but it's not capturing the upward trend, right? So if I extrapolate it all the way to the right, so probably, I don't know, all the Junes are going to be here. But we know that there is this upward trend as well. But we say it's good enough, if your model can outbid this seasonal naive forecaster for the next 24 months, I would say you have a good model. So for this time series, because of the nature of time series, a good benchmark for airline passenger is a seasonal naive forecaster, not the mean forecast or even the DRE forecast. So if your model can outbid seasonal naive forecaster, then we can talk. You have something in your hands. All right, now let's look into the same data set, airline passenger data. But instead of looking at the multi-horizon forecast, we're going to look into one-step forecast, right? One-step ahead forecast. And as you can see, I'm only showing one of those benchmarks, which is typically when you're doing one-step ahead forecast, a forecaster is your go-to benchmark, because simply saying that today's value is your forecast for next period value. That's it, right? So here, for example, remember this is our test set. Let's use the laser. Okay, so this is our test set, right? And imagine this is January. I'm going to use this value for next February. I'm going to use February's value for next March. I'm going to use next March value for April, and etc., right? And as you can see, this is as if you're shifting the data one step forward, right? So these are your forecasts. And yeah, sometimes it's hard to outbid this simple forecasting benchmark. And that's the one step ahead naive forecaster for our airline passenger dataset. All right, now let's look into some of the benchmarks for our less well-behaved dataset, which is stock price, right? So remember, this is your Apple adjusted close from 2021 all the way to 2020. I think, let's say this is October 2023. And this is close price, and we are going to create our benchmark. So the yellow one, this is our mean forecaster, which obviously it's not gonna be a fair benchmark, simply because there's upward trend, overall upward trend here, and this is going to miss that. Then our drift forecaster, if you connect this one with this one and extrapolate, this is our drift forecaster. Then we have our naive forecaster. Naive forecaster just use the past value for all the future forecasting horizon. And then finally, we have seasonal naive forecast. In the stock price, there's, especially when you're using daily data, there's not much seasonality. And depending on what forecasting horizon you're using, or what were the past, I don't know, last observation that you were including in the model, this seasonality might seem different. So sometimes it's exaggerated like this, sometimes there's nothing. It's pretty much the same as naive forecaster. So these are your benchmarks for multi-horizon forecast, right? Pay attention, this is for multi-horizon forecast. On the next slide, I'm going to show you the benchmark for one step ahead forecast, which is typically the naive forecaster, and then we're going to use it as a benchmark. All right, our last example is showing one step ahead naive forecast for our Apple stock price, right? So again, the blue one is your train set, the green one is your test set, and the dash red one is your predictions. These are naive forecasts. it might seem very promising, but pay very good attention. There are a couple of things you need to know. Let me actually zoom in a little bit into this test set only and see what are the predictions, right? So here's the zoom in version, and there's no surprise here. Basically, your forecasts are as if you're shifting the actual data one step ahead forward, right? And so look at that. As you can see, sometimes it is super hard to outbid this one step ahead naive forecaster, right? And by the end of this course, you're going to learn some tools and techniques that can outbid this one. You can perform better than naive. It's not simple. Not all the models are able to do that. But I'm going to show you some models or some tricks to be able to outperform the naive forecaster when it comes to stock price. But so what? Does it mean that you can make money based on that? So please pay attention. There's a huge difference between stock price prediction and writing a money-making trading strategies. These are two different things. In this course, we're not talking about creating a trading strategy based on your forecasting models. We're simply saying, do you have a model that can outbid a simple naive forecaster when it comes to stock price? The answer is yes. Then can I make money with that model? The answer is it depends. There are gazillion different ways that you can write a trading strategy. Let me show you a numerical example. Hopefully it makes more sense. So for example, this is your naive forecaster, and we are here in the test set. And you know that you're going to use this value. Let's say it is, let me actually use some highlighter. We're here, right? So we're going to use this value. Let's say it is 177, right? So the price is $177. So I'm going to say tomorrow's price is going to be 177, okay? And so this is what we are going to use. But it seems that tomorrow the actual value ended up with 178. Of course, actual values are going to deviate from your one step ahead naive forecaster. This is fact, right? Because if you look at the mean absolute percentage error over the entire test set, it's a positive number. It means that on average, your model is making 2%, 3% errors, right? So those errors simply means that, obviously, if you simply run a naive trading strategy, you're going to lose money no matter what. So one simple trading strategy can be simple like this. Okay, if your price tomorrow deviates from the forecast, so for example, this is, that tomorrow the price should be 177, but market opens and it's 178, and you want to say, you know what, if it is deviating 1 standard deviation, 2 standard deviation from that forecast, let's just sell it, right? So for example, if it is going up, sell it to come back down. So this is a mean reversion strategy. Again, one of thousands of different trading strategies that you can write on top of a forecasting models. So please pay attention. In this course, I'm not showing you trading strategies. I'm just showing you some models that can outbid this naive forecaster when it comes to stock price. This alone is a big deal, right? Because so many of the classical models, and as we're going to see down the road in the course, are not even able to outbid this simple naive forecaster. All right, that was pretty much it. Everything you needed to know about forecasting benchmarks. This concludes our part 2 of module 1, demystifying time series data and modeling. So in part 1, we talked about some basics. In part 2, we covered forecasting strategies. And in the next part, I'm going to talk about modeling. So no matter what model we use, we are going to show the performance of those models for 3 different types of forecasting strategies: one step ahead, multi-step ahead, and multi-output forecasting horizons, right? And then we're going to mostly focus on univariate time series forecasting. And now we know we're familiar with the benchmark. So we are going to always report a fair benchmark for our time series, depending on the nature of that time series. And we're going to look at the performance of that model, whatever it is, compared to those benchmarks for one step, multi-step, and multi-output horizon. All right, until the next one, take care. If you're looking to stay updated with the latest versions of the course's materials, please make sure to follow my GitHub and remember to refresh your repositories periodically. If you find yourself needing a bit more background in econometrics, machine learning, or deep learning, check out my other YouTube videos for additional insights. And for all the latest news and quick updates, don't forget to follow me on Twitter. Thanks for joining me, and let's keep learning together.